Welcome to Alpha Bike X assembly video. I am Ali Sadat. I will be your guide through the assembly process step by step, and together we will bring your bike to life. Without further ado, let's begin. To access built-in instructions, navigate to Alpha Bike X product page on Sadat Akhavi Academy. You can find complete assembly instructions here. Here is a list of recommended tools to build this kit, followed by kit's list of inventory and electronic components inventory. In the 3D printing section, you can find the details and locations of files you need to print to build this kit. If you are using a service provider, there is a file called 3D printing asset sheet, which includes only the details the service provider requires to print these files. To download the files, click on the link which takes you to Thingiverse. Then click on Download All. Navigate to the downloaded file, right-click and click Extract. Open your printer slicer application. Configure your printer. Drag one of the files to the build plate. Ensure it is correctly seated on the plate. Select the filament type and set the bed and nozzle temperatures as recommended by your filament manufacturer. Click on the slice and save the file to the disk. Repeat the same process for all files. In this section, we will upload the kit software to the microcontroller. Begin by connecting the microcontroller. Then navigate to Device Manager. Your board should appear under Ports. If it doesn't, or if it appears under Other Devices, you don't have the proper driver for the communication chip installed. Click on the provided link or search for the driver file. Download the file for your operating system and follow the installation process. In this section, we are installing VS Code and the Platform IO extension. Platform IO is a common IDE used to program microcontrollers. Navigate to the VS Code download page and download the proper version of VS Code for your operating system. Start with the installation process and follow the recommended steps. In VS Code, click on the extensions icon. Then search for Platform IO and click on Install. Here, we move to downloading the project's code and applying the proper changes. To download the code, visit the project's web page and click on Software Firmware link. Download the code as a zip file and extract it. Open Platform IO IDE. Navigate to the Projects folder. Open the project in Platform IO. To configure the data communication channel between your bike and Turbo Thumb controller, go to Setting and structs.hpp file and ensure the RF data channel value is the same as the one shown on the display of Turbo Thumb controller. This value should be between 0 and 125. Here, we are giving your device a unique ID, value between 1 and E. You will be using the left side keyboard on your remote controller to select which device you are controlling and sending the control commands to. To configure Platform I/O to communicate with the microcontroller, navigate to the devices. Make sure the microcontroller is connected to your PC and click on refresh. Copy the port number and name. We use these values to configure Platform I/O config file, helping it to understand which device it has to upload the compile code to. Paste the value for the upload and monitoring ports in the platform io.ini file. Now we are ready to upload the code to the microcontroller. Click on Upload button, which is a button with an arrow icon at the bottom bar of VS Code. To check if the microcontroller is programmed correctly, click on Serial Port Monitoring button, which is a button with a power plug icon. You should be able to see some incoming logs from the microcontroller. Assembly of electronics. We start soldering of electronic components from the servo motor connector. In your kit, it might be an individual 3-pin connector provided in the kit, or you might have a long connector that you need to break it using a wire clipper. Next is the RF connector, a 2x4-pin connector to be placed at the J8 location on the PCB. To dissipate heat and avoid damaging the components, I start by soldering every other leg and then completing all connections on the second round. Next, we move to the H-bridge motor connector, a 6-pin connector. It might be an individual connector provided in the kit or a long connector that you need to break using a wire clipper. Next is the 2-pin headlight connector. Our last connectors are microcontroller 20-pin female connector for the H2 and H3 locations. These connectors are used to mount the microcontroller dev board on the PCB. I start by soldering one leg to ensure it is correctly placed. Once it looks good, I proceed with soldering the other legs of the connector, starting by soldering every other leg and finishing all legs at the second round. This helps with avoiding overheating the connector and cross-connecting the connections. Let's repeat the same process for the second connector. Soldering just one leg, making adjustments if needed, then continuing to solder all legs in 2 rounds. Resistors are important components in electronics with many use cases like current limitation, voltage division, and much more. Their values can be identified using the color bands on their body. You can decode the color coding using the links provided. The first link is a guide on how the color coding works, and the second link is an online converter. Here you can find a table of the kit's resistors. You might have 4 or 5 band resistors in your kit. Starting with R1 resistor. Resistors don't have orientations and can be placed in any direction. Put the resistor in its place and bend its legs at the back. Then place R2 and R3 resistors. Next is R4 resistor. And finally, the R5 resistor. Solder the legs at the back of the PCB and cut the excess using a wire clipper. Diodes are important electronic components that allow current to flow in one direction. They are polarized components and need to be connected in a specific orientation. The white band on the diode body is closer to the cathode leg or negative leg. Place the diode with the white band aligned with the white band on the PCB, indicating the correct direction of the placement. Soldering electrolytic capacitors. This kit has 3 electrolytic capacitors and 1 ceramic capacitor. Electrolytic capacitors have 2 legs with different polarities. Shorter leg is cathode or negative. There is a mark on capacitor body pointing to the cathode leg. The longer leg is anode or positive. Place the capacitors into their locations. Ensure the positive leg goes into the positive hole indicated by plus sign. Bend the legs at the back, solder, and cut the excess leg. Soldering ceramic capacitors. Ceramic capacitors don't have polarities and can be placed in any direction. Place the capacitor in its place, bend the legs at the back, solder, and cut the excess legs. Soldering transistor. This kit has 1 NPN transistor for the piezo motor driver circuit. Transistors have 3 legs: collector, emitter, and base. You can identify these legs by a cut on the transistor body. In this type of transistor, when the cut is facing you, the right leg is emitter, the middle is the base, and the left is the collector. Place the component, bend the legs at the back, solder, and cut the excess legs. Soldering voltage regulator. This kit uses a voltage regulator to stabilize incoming power from the battery pack for the servo motor. The 7805 voltage regulator has 3 legs: input, ground, and output. The metallic part of the regulator acts as a heat radiator. It should match the location shown on the PCB. Place the component, bend the legs at the back, solder, and cut the excess legs. Soldering buzzer. This controller board has a passive buzzer with positive and negative polarities. The positive leg can be identified by the plus sign on the top of the casing. Place the buzzer in the location shown. Ensure the positive leg goes to the positive hole indicated by the plus sign, and solder the legs. Soldering power connector. This kit uses a 9-volt battery connector, which should be soldered to the indicated location. Strip the connector wires, with the red wire going to the hole with positive sign, and the black wire going to the hole with negative sign. Solder the wires and cut the extra wire. Soldering power switch. Alpha Bike uses a rocker switch as its power switch. To connect the switch to the board, we need 2 pieces of wire. Strip the wires and solder one end to the switch and the other end to the PCB board. Be careful while soldering the switch to avoid overheating the legs, as these legs can transmit heat very fast and melt the switch. Next, connect the H-bridge motor driver module. It's a L298N motor driver module. It can drive 2 DC motors in different directions. Start by stripping and soldering 3 wires to the PCB. Then connect the other end of the wire to the L298N module as follows. Wire connected to 12 volt on PCB goes to 12 volt pin on the driver module. Wire connected to the ground on the PCB goes to the ground pin or the middle pin on the driver module. Wire connected to 5 volt on PCB should be connected to the 5 volt pin on the driver module. Connecting RF module. Connect the RF module to the board using wires as shown. This sensitive module has 2 rows of 4 connectors. Hold the module on the side of the controller board like this and use a 4-pin connector to connect each row of the RF module to the connector board. Connecting servo motor. Connect the servo motor to the controller board. This servo motor controls the steering of your bike. To ensure the motor is connected correctly, the wire colors should be as follows: brown to ground, red 5 volt, orange to signal. LEDs have positive and negative legs, which can be identified in several ways. The positive leg, or anode, is longer, and the negative leg, or cathode, is shorter. The casing of LEDs have a flat edge on the negative side. If you look inside the LED, the positive leg inside has a smaller internal structure. The Alpha Bike X has a 10mm LED for the front light, and we will use 2 pairs of wires to connect it to the board. The positive leg, or anode, is longer, and the negative leg, or cathode, is shorter. Cut the LED legs and connect the LED to the PCB using wires. Ensure the positive leg connects to the positive terminal on the board. Now we can place the microcontroller in its place and start testing. The microcontroller dev board has 19 pins, and the female connector on the board has 20 pins. 1 extra female pin. We need to ensure the microcontroller is placed correctly, and 1 extra pin that is not going to be used is close to the edge of the board. Testing. The electronic assembly is now complete. To test the board before installing it to the main chassis, connect a 9-volt battery to the board and turn on the power switch. The LED should turn on and the servo motor should rotate to the predefined 90 degrees position. I use a tape to demonstrate the movement of the servo motor. Now we are ready to proceed to the hardware assembly. We start the assembly from the rear drive wheels, the tires made of TPU or TPE, and they are flexible and should fit easily onto the rims. Use 2 screws for each wheel to secure the wheel connector shaft. Motor drive assembly. Connect 2 wires to the TT motor. Strip one end of each wire and twist it well for a secure connection to the TT motor pins. You can solder these wires, but be cautious, as the connectors of TT motors are very sensitive to the heat and may melt quickly. Instead, I'm carefully twisting the wires onto the connectors. Mount the TT motor to the motor mount using spring and 2 screws. Partially insert 1 screw to joint assembly. This screw will be removed later for another part integration. Use the other screw to secure the spring. Then, attach the previously assembled drive wheels to the motor. Middle connector module. Attach the servo motor horn to the front connector module. Use the servo horn provided in the servo motor package and secure it with 2 self-tapping screws included in the package. Servo motor mount. Disconnect the servo motor from the controller PCB. Mount the servo motors to the front wheel horn using 4 M3 screws. Install the 4 shock absorbers provided in the servo motor package. Place the servo motor in its designated position and secure it with the screws. Front and middle section integration. Integrate the front and middle sections of the bike. To ensure the servo motor is at the 90-degree position, connect it to the board. Turn on the board using a 9-volt battery, ensuring the servo motor moves to the 90-degree position. Check the alignment of servo motor by turning it slightly when the board is powered off. Turn the board on and off again. The servo motor should return to the correct position. MCU mount. Install the MCU mount. Use a long screw provided to connect the MCU mount to the previously built assembly. Install the handlebar using 2 screws. Pass the servo motor wire through the designated passage. Front wheel assembly. Mount the tire onto the rim. Place the bearings on both sides of the rim, and then install the front wheel connector on top of the bearings. Secure the front wheel with a long screw. Headlight LED. Disconnect the headlight LED from the controller board. Pass the wires through the handlebar passage. Connect them to the LED and mount the LED in place. You can use a hot glue gun to secure the LED if needed. Motor drive module integration. Install the motor drive module underneath the main chassis. Secure it with 2 small M3 screws. Battery basket holder. Place the battery basket holder underneath the chassis and secure it with a M3 screw. Battery basket. Install the battery basket underneath the bike. Secure it with 2 long screws, one for the joint and another to secure the basket using the basket holder. Electronics integration. Start integrating the electronics into the main chassis. Pass the battery connector through the hole in the chassis. Mount the PCB board to the chassis using 3 short screws. RF module and MCU box. Install the RF module. Align it according to the instruction. Place the MCU box on top of the chassis and align the holes with the motor module joint. Unscrew the back joint screw. Align all the holes and screw it back in place. Ensure proper alignment to avoid damaging plastic parts. Install the power switch by passing the wires through the gap. Positioning the off state or O downwards for consistency. Install the L298 H-bridge module. Place the module on top and screw it with 3 M3 screws. DC motor connection. Pass the TT motor wires through the holes. You may need to remove one wheel to do this. Connect the TT motor wires to the motor output of the L298 module. Either side is fine. Connect the 6 data pins of the module to the controller PCB. If there is a jumper on these connectors, it is safe to remove them as they are unnecessary. Follow the assembly document for wiring. Final step. Connect the servo motor to the controller board and connect the LED to the PCB using wires. Close the MCU box by sliding the large lid under the L298 module and loosely fastening a small screw to hold it in place. Use 2 long screws for the front of the lid and 1 short screw for the middle. Once all screws are in place, tighten them securely. Now, test your Alpha bike. Use the turbo thumb controller to control the bike. If the bike responds for forward and reverse commands in reverse, switch the placement of these 2 wires to correct the issue. Now you can install the complete battery pack and enjoy riding your Alpha bike. Congratulations on completing the kit. I hope you learned something new today and had fun. If you would like to support my work, please like, share, and subscribe to my channel. And join our Discord server and leave a comment. Thank you for watching. Looking forward to seeing you in the next one.